This will be a complete Pandas tutorial for beginners and for data scientists, for programmers. And I'm going to quickly start because it's going to be a fully practical tutorial. The first thing you want to do is to install Anaconda. If you install Anaconda, it will give you, it will provide you with Jupyter Notebook. So here I have Anaconda 3. You have Jupyter Notebook, simply open it. When you open it, it opens up the browser right here. So I'm just going to save this tutorial as Pandas tutorial. This file, I'm going to save this Pandas tutorial. If you're joining me for the first time, click on the subscribe button so that you don't miss any updates. So this is going to be the easiest and very simple tutorial to follow for everyone. So the first thing you want to know is that Pandas is a module that you use with Python, and it helps you to manage data, to analyze data, to filter data, and to carry out any other analysis and operations on data sets. So this data can come from any source, from JSON, from Excel, from CSV, from TST file or text file, from SQL. But now we are going to be focusing on not the very difficult part. Let's start simple and then gradually we move on. So the first thing we want to do is to import Pandas as PD, and let's also import NumPy, because each time you are working with Pandas, you may also have to do some arithmetic. So NumPy is used for carrying out some arithmetic, mathematical operations on your data. So the first thing we want to do is to see how to open a data set. Now the first thing I like to tell you is that there is a difference between a data frame and a data series. So let me see if I can illustrate the difference. For instance, if you have something like A is equal to, let's say we have 1, 2, 3, 1, 2, 3. We also have 2, 3, 4. So now what we have here is called an array. So if I say print A, you see we have is an array. Okay, I can also say A is equal to mp dot array, and I give it A. So if at this point, if I say A, you are going to see that it arranges itself like a tabular data, but this is not a data frame. It's just a tabular data. It can be row and column, but it's not a data frame. This is called a NumPy array. So let's now talk about Pandas data frame. So let's create a simple data frame. I think I have one on my clipboard. Let me see. I have one I created before now. So let's see. Let me just create a data frame. B is equal to pd dot data frame, and then specify. It should be. Well, the first thing we want to do is let's just create something called a dictionary. So I'm going to say data is equal to I open a curly braces and say A. Let's say A. Okay, let me just leave it at A, and then I have a list of items 1, 2, 3, 4, and put a comma, and I think I should have this list to be like this. Okay, and the second one should be B, and I put a colon, and I have 3, 4, 5, 6. All right, so I'm going to execute it now if everything is okay. So let me create a data frame from this. This is going to be a data frame and not a NumPy array. So I can say my df, my data frame maybe equals pd dot data frame, and I give it the data I created. Now what I created here is called a dictionary. So let me run this. Hopefully it's going to work. Now if you want to see how a data frame looks like, you can just say my data frame is going to print out what a data frame looks like, and you can see that it's very much different from a NumPy array. Data frame arranges data in a tabular way and is in a very clear way. All right. Alright, so this is how a data frame looks like. And now the next thing we want to do is we want to load a data frame from a CSV, or let's say import data into a data frame from a CSV file. So I have in my system a CSV file I would like to import. So to import, you are going to be using something called read_CSV. For instance, I can say df1, data frame 1, is equal to pd.read_CSV, and then specify the location of the data. In my case, it's located in the data folder, and the name is iris.csv, and I'm going to run it at this point. So if I want to view what is in df, I can just say df1, and you can see that it displays the content of the data frame. So this data frame is a CSV file. Maybe I could even show you this this CSV file in my system, iris.csv right here. So that is what we just imported into Pandas, and that is really very good. All right. Let's see. So this data set I have, if you look in the description box, you can find this link to the CSV. You can download it and use it for anything you want. Let's try to import another data frame. df is equal to pd.read_CSV. Sometimes you might not succeed, and then I'll show you what to do. Let's say the data frame is difficult to read. For instance, let's say we have let's try auto.csv. Let me see how it looks like. Okay, let's try this auto.csv. Auto.csv. Okay, yeah, let's try auto.csv. Let's see. Data, and let's say auto.csv. And if I run it at this point, now see the problem we are going to have. If we try to view the data frame, you see that it is messed up, right? So this is not exactly what we want. So to do it correctly, you check the delimiter or the separation between the data. In this case, the separation is tab, so you can say delim. I think that is it. Delim is equal to \t. All right, so let me import again by saying run. I think it's going to be sep instead of delim, sep. All right, so view the data frame again. So you see it makes some sense, as you can see. So, but it seems it's not quite well. So let me put one more parameter here and say engine equal to Python. All right, so let's go again. And okay, we have exactly the same thing, so it's okay. So this is how to import a CSV file. And let me just go for the last time. All these data sets, you can find them below. Let me try to import Titanic.csv. I don't know exactly how it looks like, but let me just open it. Titanic.csv. Let's see. Okay, I'm now importing the Titanic.csv. Okay, this time let's try query.csv. I don't know how it looks like, but let me just check query.csv. Okay. So let's try to import this brain size.csv. So I'm going to say import df is equal to pd.read_CSV, and it's going to be the brain_size.csv. All right, so I'm going to run, and then brain size.csv. Let's see what the problem is. Brain_size.csv. So it says file brain_size.csv, so does not exist. So it's actually the data. All right, so let me run it at this point. Okay, fine. Now, if I look at df, you see that there seems to be a problem. It's not quite well. What I want to help you understand is you need to understand the separation between the data. So you have semicolon to be the separation. So you need to simply specify here SCP is equal to semicolon and just run it again, and now everything is perfectly okay. How about reading from an Excel file? So reading from an Excel file, let's see. So let's say we have let's say wine.excel, wine.slsx. So to read from an Excel file, if you do the same thing we did, let's say df is equal to pd dot read underscore Excel and specify the slide data wine dot xlsx. So let's see, now we have, okay, it's right. So I'm going to say df just to check what is in there. And it's also perfectly well. So in this case, we are using pd.read underscore Excel. All right, so this is how to read data from a CSV file from your system. So I hope you understand it. And again, you can also say read underscore table. That also works. If you have another data format, you can say read underscore table. For instance, if I have some other data format, for instance, .data, like you have this iris.data, you can say read underscore table. That will work. All right, let me read for one last time. Let me just read another data set I found online on a friend's blog. So I'm going to say df is equal to read underscore CSV, and this time is going to be d slash data slash the name is Pandas underscore tutorial underscore read dot CSV. So I'm going to run it at this point. Let's see. Let's see the name of the data set. Let's see. So have Pandas tutorial underscore read. Pandas tutorial underscore read. Pandas tutorial underscore read. So it says name read underscore CSV. So it's actually pd dot read underscore CSV. So if I check the data frame at this point, you can see that it actually doesn't make much sense. But in this case, what do? Simply specify the separation to be semicolon. You can say delimiter, or you can say SEP, that is for sep, or for separation. So if you put this, that will be fine. So if I run it at this point and view the data set, you can see everything is perfectly okay. Alright, so one thing I want you to notice at this point is that the Pandas have already added one column that is not included in the data set. This column added here is called the index column, which is an auto increment column from 0 all the way to 1793, which is the total number of items or rows in the data set. Alright, so what do we continue with? Alright, so what I'd like to do is to specify a different column names for the columns of this data set. So we have these column names. They're actually not the real column names. This actually is the first row of the data, right? So it actually has no columns. So if I go back to my data and I open this data in Excel at this point, you can see that there is no header in this data set. So we are going to use Pandas to add header row or header to the data set. So I'm simply going to repeat the import statement, and this time I'm going to specify the column names. So I'm going to specify column names. The names I want to add is going to be dates. I just call it events dates. Events dates. So I'm going to create it like a list. So event date, and the next item there is event or operation. The next item there is a country, and the next item is user, user ID, okay, and the next item there is the source, and finally the next item is the topic. Okay, so it's a list, so I'm going to just close up this. I'm going to capitalize this as well, capitalize this as well. So these are column names I want to use for this data set. So how do I include it in this place? So I'll simply say, when I'm reading the data set, I can just specify the columns by saying something like, I'm just gonna I'm going to restore this screen so that you'll be able to see it without my interrupting anything. Okay, sorry, let's just continue. So you can just say names, comma, names equal to column underscore names. So these are the column names we specify here, and it's going to add this column exactly respectively the way they appear on the dataset. So I'm going to run again at this point, and if I view my dataset, you can see that columns have been added, which is beautiful, as you can see right there. All right, let's now talk about something very important. How do we select data from a dataset? So how do we select data from a data frame? All right. Before I continue, I'd like to mention that you can actually insert a cell above an empty set. So if you want to see the first 5 items of your data frame, you can say df.head. You can now specify how many items you want to view, and you can run it, and it displays the first 5 items of the data set. So of course, you can also say df.tail, so it displays the last 5 items on the data set, as you can see, 1790, 1791, all the way to the end. All right, let's now talk about selecting items from the data set. Okay, so one way to select items from the data set, let's say we want to select only one column, for instance, the event date. Actually, there are 2 ways to do it, but let's take the simple one first. So I'm going to say df and just specify the columns you want to select. In this case, specify two opening square brackets and specify the column. In this case, events date. So it's going to actually select only the first column as df. Let's see, events date. See, I think it's going to be just one. All right. All right, so the problem is that I need to use the actual case. So it's going to be lowercase for date. All right, so I selected only the first column at this point, and if I use two square brackets, you can see it's selected very nicely. You can actually specify another column here. It may be consecutive, it may not be consecutive, but you can specify 2 columns. You can actually specify 3. So at this point, I'm going to jump to the last one, which is topic. So I'm going to say topic, and you can see that it works perfectly well, as you can see right there. All right. So this is how to select items from the data set. Now you can also do it in a different way by using the selection operator, which is dot. So I'm going to say df dot events date. This will also work. I've not used it. I don't use it so much, but I think it also works. So if I want it to be, I can just say print. I don't know. If I print it out, I think it's going to be the same thing. But in this case, it tends not to be a data frame. So df. Yeah. So this is what we have right here. Now let's say we have this our data set and want to filter only topics from Asia or topics from Europe. How do we select only topics from Europe? So you can say, for instance, you can say df dot df, okay, and you specify the selection criteria. So in this case, I'm going to say topic equal to double equal to, and I can say Asia. So in this case, I'm saying select filter the data frame for where topic is equal to Asia. So I'm going to run it at this point. So it says topic not found. Why? Let's see. So let's see. Okay, so actually that is you are going to say df dot topic equals to Asia. So it's going to filter only for Asia. So you can see the topics is only for Asia. So let me try something. So if I say df specify it in this way, df topic. I don't know if this will work, but let's see. So let me run it. So it also works. So you can actually select in two ways. All right. So the assignment I'm giving you, select for where source is equal to SEO. All right. Select for only where the source is equal to SEO. So let's say you want a list of items where source is equal to SEO and topic is equal to Asia. So you can also specify, let's say, using the and symbol and df this time df source equal to SEO. So I'm going to run it at this point. So it says invalid syntax. I think it's a single ampersand, not double. Okay, so cannot be compared. Okay, I think we need to just write and in lowercase. I can't remember. Let's just write it in lowercase. So all right, look. So let's now talk about combining different functions. One function you learned or one method you learned is about df.head, and we can select maybe 4 or maybe 3 at this point. Now I want to combine df.head and want to also select only for operation and user ID. So I can specify operation and user ID. So in this case, we are filtering the data and we are combining it with this. So this is tend to be called piping in some programming languages. So this line selects the first 3 items of the data set, and then it takes only the operation and the user ID. You can get the same result with a different way. You can say something like df and specify this for the first part of the operation, and specify the next part user ID, and finally you say dot head. So that's going to give you exactly the same thing. Now specify 3 items because 3 items is what we want, and that gives us exactly the same thing. One more thing: what happens when you replace the data frame with the original CSV function, right? So for instance, instead of to use df, you use exactly the read function. For instance, let's just go all the way back up, like here. Let's just say we have here. So this line I'm copying here is the same as df. So if I place it right here, Control V, place it right there and run it, it's going to give us exactly the same thing as well. Alright, so we've done so well. I'd like to recommend you play around with this, and then the next part we are going to see the much we can do. So let's now look at how to aggregate or how to combine data in Pandas. All right. So there is a data set I'm going to like to load. Data set is zoo data. I call it zoo_data is equal to pd. Maybe I'm just going to paste this and just change this to zoo.csv. Alright, so the delimiter, column names, I'm gonna take out this, I don't know, but let me just read it first, then we see how it goes. Zoo_data, so I'm trying to read this data and see, okay, so fine. So zoo data has animal, unique ID, and water need, alright? So what we are going to do now, I'm going to show you how to merge 2 different data sets. Alright, so the first thing we want to do, let's check the number of rows in this data set. We calculate the sum, the total of the water need column. We check the total of this column, check the total of this, and also find out which is the minimum value here, and then we find the greatest value and also the average water need. So let's see. So our data set is zoo data. So the first thing I was saying is we need to count. So to count, we use a function called count. So I can say zoo data.count. So for functions, you use after calling the function, you need to specify brackets. So I'm going to run it. So it tells us animals is 22, unique ID 22, water need 22. So it gives us a count. So the next thing we want to do is to do sum. So I'm going to say zoo data.sum. So it's going to give us the sum of all of the columns in the data set. So in this case we have, let's see, okay, so in this case you see it's actually doing summation of the animals to be summing up as the strings, but that is not possible. So we can sum the unique ID, we can also sum the water need. Alright, so the next thing we want to do is the mean, minimum, and maximum. So I'm going to say so in this case we want to find out the minimum of each of the columns. So you can say that mean is going to give us the minimum of each of the columns. So the minimum unique ID is 1001, and the max and minimum water need is 80. And you can also do the same for max, and it's going to give you exactly the same thing. We also have another one like mean and median. So you can just say zoo underscore data dot mean. So to get the mean values, I'm going to just run it and you can see the mean values. You can also get the median, right? Alright, so to get all these things very easily, instead of to do them one by one, you can just say zoo data dot describe. If I can still remember it, describe, that will give us everything that we've been looking for. So for unique ID and for water need, it gives us the count, the mean, the mean, and the marks as well. So somehow the sum is not here. Alright, so one thing we are going to now be talking about, which is very important in data analytics, is grouping data. So as a data analyst or a data scientist, you need to understand how to group data. Pandas is a starting point for grouping data sets. Alright, so what does it mean? For instance, in this data set, we have elephant, we have tiger, we have zebra, we have lion. So how do we group them all together separately? So it happens that Pandas gives us a very, very beautiful function called group by. So we are going to be using a function called group by as one word. So let's see how it works. So I'm going to just start a new cell at this point. I'm going to say zoo underscore data dot group by. So when you say group by, you need to specify the columns you want to group by. So in this case, the columns are animal. We want to group it by animal. So specify animal right there. Okay. Just for curiosity, I'm going to just run this code just for curiosity. Now, when you do this, nothing shows up because it is a generic group by object. So after grouping, you can now find the sum or the mean or whatever you want to find or you want to find. So here you have mean. So you have elephant, kangaroo, lion, tiger, giving us the mean of all of them. And the same way you can have the sum, and you can also have all these other functions that we've also talked about, and that is really very, very good. So what if you want to group by and we only want to take just the water need? So we can append it here. So we can just append it here and say water underscore need. So in this case, we are selecting only one of the columns, and if I run it at this point, it gives us the animal and the water need. Alright, so this is also called aggregation. So we are aggregating, we are grouping, either of the two is fine. Alright, so the next thing we want to do is to play around. This one I'm going to allow you to do it. Group by unique ID. Yeah. So and there's a let's get another data set and see if we can do a little more of aggregation. So this is the data set we used originally. So let me just go up and copy this data set. Let's see. Not this one. Not this one. So this data set right here. So let me just copy it out. Copy. So let me paste it again and let's run it. So we have a data frame called df. So now you can group by. Again, I can just say df.head. I'm going to just take only one of them. Okay, so we have okay, so I'm going to just say columns equals names is equal to column names. Names is equal to column names. Let me see where I had it, because remember we changed the column names at some point. Alright, so we have, let's see, yeah. So we have column names here, which we did change at some point. Alright, so let me run it again and let's see. Run. So we have good column names at that point. So let's group this data frame by the source. Let's group it by the source. We want to know all the sources, all the unique sources there. So I can say df dot group by, and I specify source. Okay, and let's just count the sources. Okay, so I'm going to run it at this point, and it groups by source. We have the sources to be AdWords, Ready, and SEO. We can also group by operation. Let me try group by operation. When I group by operation, I also have only one operation. Wow, that is read operation. And finally, let's try to group by topic. So group by topic returns, we have only 6 topics: Africa, Asia, Australia, Europe, North America, and South America. All right? Okay, so this is how the group by function works. So play around with it, and I'll recommend you just, if you have challenges, let me know. If you are joining for the first time, you've not subscribed to my channel, hit the subscribe button below. Let's now talk about data cleaning or data manipulation. We are going to be talking about merge, sort, reset index, and filling missing values. So let me just outline what we are going to talk about. We are going to be talking about merge, sort, reset, index, and fill NA. And then we're also going to be talking about manually creating a data frame. Manually creating a data frame. So this time we are not importing it from anywhere. We are trying to manually create a data frame. So I'll recommend that we create a data frame called ZooIt. So this name of the data frame, I saw it in a friend's blog as well, a friend of mine. I can't figure out his name. I think his name is, let me see. I think his name is Tommy Mester, that's his name. So he's a good friend of mine, and I got this data from him. So let's create a data frame. I'm just going to call this data frame ZooIt is equal to pd dot data frame. I already taught you how to create a data frame from a dictionary. So let's just create a dictionary first. Dic. Okay, let's call it di. That's di for dictionary. I'm going to say create a dictionary. You start it in this way and specify the column name animal. This is the column name or the column header, and the items there is going to be elephant, a half, Alright, so this is the first item, or let's say the first column. Let's create another column for food. So basically, elephant eat vegetables, tigers eat meat, and kangaroo eat vegetables as well. The zebra eat meat. I don't know. I don't know. So let's just use it for demo purposes. All right. So we have created a dictionary, and if I run it, we have this is called a dictionary. And to now create a data frame from the dictionary, I'm going to just say ZooIt. Let me call this name of the data frame I'm creating. I'm going to call it ZooIt. ZooIt is equal to pd dot data frame and specify the name of the dictionary that I created here. So if I check zoo, underscore eats. Let's see if we have a good data frame. And there we have a good data frame right there. So we have a data frame DI. We have a data frame DF, and we have a data frame called ZooEat. Now, this DF, I want to assign it to another data frame called Zoo. So instead of using DF, I'm going to use Zoo. All right, so let me call it Zoo. All right, so we have Zoo and we have ZooEat. So if I say Zoo dot head, so it's exactly the same data frame we have for wait, no. So this is not. So I think we call it Zoo data. Sorry, you call it Zoo data. So please forgive me for this error. Zoo data, and we have the head. Alright, so we have the head. So we have Zoo data. We also have ZooEat. So we have Zoo data containing all the animals, and we have ZooEat containing the animals and the food they eat. So what we want to do now is to merge these two tables, right? We want to merge these two tables. So what do? What we can do is to use a function called merge, right? We're going to use a function called merge. So I'm going to say zoodata.merge. So let's create a new data set. Let me call it all underscore data is equal to zoodata.merge, and specify the data you want to the data frame you want to merge into this data frame. And in this case, the data frame I want to merge here is zoo underscore eats. So I'm going to just run this. So if I check what is contained in all data, you'll see that it has been merged. Everything has actually been merged. How do I know? I know because I now have food, because food was not in the previous one. But what you can see that we have animal in the original one, and we also have animal. We have animal in ZooEat and we have animal in ZooData. So in this case, we have only one column animal, and it's merged downwards. And in this case of food, it wasn't there originally, so it's going to be added to the data set. All right, so first I specified the data frame ZooData, then I applied the .merge command from Pandas on it and gave it as a parameter ZooEat. So I could also have done it not the other way around. I could have also said ZooEats.merge and provide to data, and if I run this at this point, it's going to also give us exactly the same data set we have originally. So this is just a different way of doing it. Alright, so this is how to merge data set, but there is something called joins in SQL. I actually would not have loved to get into this, but let's just specify some parameters, for instance, outer join, inner join, and so on. So when we talk about outer join, we have ZooEats.merge, ZooData. It takes all the ZooEats, okay, and merges it with all items in the ZooData and provides all the data sets. Even though when we have, so the easiest way to understand it is to just run it. So I'm going to say ZooData.merge, and I'm going to say zoo underscore eats. Now the parameter you need to specify is called how is equal to outer. So once I do this and I run this command, you can see that we can see some data has been merged here. In this case, this data is coming from the zoo data, but there is no food specified in ZooData. So this is you are specifying all the items, both where there is a matching item in zoo data and both where there is non-matching item in zoo it. So I would not like to actually go much about this merging. So I'd like to talk about something else. I'd like to talk about sorting. So let's say we have, let's try to make sure we have our data still okay. So we have this data set here. So let's say we want to sort these values. We want to sort by what I need from highest to from smallest to biggest. So I can say zoo. We put a comment just to indicate what we are doing. Sorting a data frame. Right, so you can just say zoo data.sort and then specify zoo data.sort. Let me just do something first. I'm going to say what I need. I think it's going to be sort values. I don't know if it's sort or sort values. So it's actually sort underscore values. Like this, sort underscore values. And I'm going to run it and it sorts it. You can see what I need is going from the smallest 80 to 100 upwards all the way. Alright, so we sort it as, and you can see, and you can sort by anything. Note that in the older version of Pandas there is sort, but in Python, in new version of Pandas, there is sort values. So sort values is not the same as sort. Sort has been deprecated. So the parameter I specify for this sort value function is the column where I want to sort. But most often you have to sort multiple columns, and in general, you can use the by keyword. Alright, so let's try to sort by multiple columns. So after sorting by water, we then sort by maybe animal, maybe. So let me just execute this. This time I'm going to sort it in two ways. So I'm going to say zoo underscore data the sort underscore values, and at this point I'm going to say by equal to, you now specify a list of items you want to sort. So I'm going to sort it by water needs, and after sorting by water need I'm going to sort it by animal. Alright, so this is a typical way of sorting spreadsheets. So if I run it at this point, zoo data the sort values, so it's not value but values, so I'm going to just run, and here you have what I need is sorted, and after that we have this animal is sorted as well. So so what next? You can also use the by keyword if you're only using one only one item. So you can actually do something like this. Alright, so this will also be good. It sorts by what I need from smallest to greatest, or in ascending order. But you can also say ascending is equal to false. So in this case, it's going to sort it in descending or in non-ascending value. So it starts at this point from the greatest one, or from the maximum value going downwards, because we specified ascending is equal to false. But what do you notice about the index? The index now, when you sort by a different column, the index now have gone haywire, because you can see that it's no longer in sorted form. You're going from 0 all the way up. So how do we correct the index after sorting? We can use something called index, or we can use something called reset index. Yeah. So how does reset index work? It simply works by saying reset index. It's as simple as that. So simply at this point, after saying ascending is equal to false, simply add another thing, dot reset index. So I'm going to just say at this end. So this is the values we have. Okay. So at the end, just say dot reset underscore index. So that's all you need to do after sorting. Just reset your index and it's going to reset. So you can see the index is reset at this point. So we have a new index 01, 0, 1, 2, and so on, all the way upwards. Alright, so although we have this index right here, you can keep it because that is the index for your original items. You can also remove it. If you want to remove it, for instance, you want to remove this index, I can remove it by saying, let me just create a new zoo. Let me call it this dataset new zoo is equal to zoo data, and just take, we have animal, unique ID, and water need. Just take take the tree. So I'm going to just say animal, unique underscore ID, and water underscore need. So new zoo is going to remove this index that is unsorted right here. Animal, unique ID, and water need. So if I run this code at this point, new zoo is equal to zoo data. So what is it saying? Key error. Let's see. Zoo data, animal, unique. Okay, unique ID. I should be unique ID. It should be something like this, if I'm not mistaken. Let's see where the problem is coming from. Okay, I think we need to use double curly brackets. We need to use double curly brackets. And if you look at new zoo at this time, you'll see that that index that is unsorted is gone. So we only have one unique index right here. Alright, so let's move on to the next one. The next thing you can also do is to sort by values, reset index, and drop the index as well. So for instance, if I come here, I can copy this. After resetting the index, I'm going to also drop the index by saying reset index and say drop is equal to 2, is equal to true. So I can just come here and say drop is equal to true. So at this point, after sorting it drops the index and only uses the sorted index, and that is pretty fine. So how do we handle missing data? In data analytics, one thing you need to learn about is handling missing data. So let me say handling missing data, and this is called data cleaning or outlier detection or feature analysis and stuff like that. So it's simply a way to clean up your data set. Alright, so let's start with doing something called trying something called a left join. So let's say we have our zoo data.merge. I have we are merging it with zoo eats and how is equal to left. Okay. So this is what we have. So at this point, do we have some missing data? Yes, we have NaN, not a number or not, simply it's missing data. That is what Python calls it, NaN. So that is called missing data. All right. So to handle this missing data, what you can do is to simply use a function called fillNA. So let's say we have this data containing missing data. Let me just call it NaZoo is equal to, so we have NaZoo now contains missing data. So if I say NaZoo, you can see that it is a data set that contains some missing data like NaN. So what I can do is to fill this with some value, right? I can also remove it completely. So there are two functions we need to know when it comes to data cleaning, and those two functions or methods I'm going to write it is called fillNA and dropNA. So these are the two functions you need to know when it comes to handling missing values. So this data set that has a missing value that I call NA-zoo. So if you want to fill the NA with some value, we can just say NA-zoo dot fill NA or fill underscore N fill NA in one word, and fill the not available values with, let's say, let's just say food. Let's say food. So if I run it at this point, you can see that this field is filled with food. If you say fill NA food, it's filled with food. Alright, so that's how to handle it. You can also fill it with anything you want. Another thing we can talk about is to drop missing values. So if I can just say, in this case, I can say it should be drop NA dot drop NA. So in this case, if I run it at this point, it drops those values that are missing. So it doesn't fill it with anything, it simply drops them. So you can see from 14, 15, 16, 17, 18 is not there. So you can see the index right here is already jumping from 14 to 19. So you can append at this point, you can say dot reset index dot reset underscore index and drop equal to true, so that it doesn't add an unnecessary index. So I can see it resets our index to be sequential as well. Alright, so we've come a long way. The next thing I'd like us to do is to So this is where this tutorial ends for Pandas, and this is actually the easy Pandas for beginners, and I'm going to be talking about more advanced Pandas after now. But basically, Pandas does not really get much complicated. It's simply a very interesting aspect of data science and Python programming. I'd like to thank you for viewing. I remain Kyneton the Genius. Please subscribe to my channel if you've not subscribed. And we'll see you in the next lesson, which is going to be NumPy full tutorial.